So one of the interesting things I find about programming is when you're working on a problem and you come up with an idea, it's very hard to let that idea go, right? It's like, oh, this is, and he's like, oh, it's getting harder and harder, but no, I gotta keep on it. I just can't let go, right? And the problem is, if it's the right idea, then fine, right? But there are times when like it's harder and harder and more complicated, and like it's not working, and it's very hard to step back. And I find you just have to just stop, right, and do something else, and come back to it. Because otherwise, you just dig and dig and work, and you just push and push and push and push. And it's like people were like, well, I want all the variables to be constants. I'm going, that's interesting. Have you ever written a program that only has constants? I don't think so, right? So why do you think we should have just constants? Well, it's because when I parse, I can just assign that value right in the parser, right? But it's a variable, right? And so people, some people are like, they ask the question once, and I go, no, you don't do that. But like, no, I can't let go of it. Ask it again. No, I can't let go of it. Well, it's actually not that hard. Once you build an assignment statement, then with the difference make we assign it once or 5 times. Now, part of the problem is that it's hard to create assignments which mix several patterns, right? Unless you make the assignment really big. Of course, you think the assignment was big, but it wasn't really, really big, right? I mean, and so there's too many patterns for the amount of code you're writing. And also, I made the language simple and small, so you have to, so the parsing didn't get huge and complicated.
So how do you go about choosing, like, obviously, how do you go about it? Most widely used or most effective?
So how do I pick which patterns to use? Most of them come from, right, the classic text, Gang of 4. And giving you assignments on the visitor pattern is one of the more complicated patterns. You got this double dispatch. And so I figured once you figure that out, once you can figure the visitor pattern out, right, the other patterns are going to be simpler. And so some of the patterns, the question becomes not how do you do it, but why do you ever do it, right? Well, if you chain of responsibility where instead of having one object, you chain them together, and each one does one piece, it's like, why would you ever do that? Not how do you do it, it's just why. What's that?
You were thinking that would be a visitor first?
No, but early on in the course, right? I'm not waiting until the end of the course to give you a visitor assignment. Actually, I wanted you not to do the visitor. I wanted you to do problem 1 first, right? Make the expression tree, make it work, and then work on the visitor. Rather than say, oh, I can skip this piece and add the visitor and just do the visitor part. Like,
What about halfway through the semester? Like, what is it that you're really getting done? We're taking out of this class, like at this, or these patterns are visible, or a certain outcome.
Well, there's a number of things. One is, think about how things are connected, right? So in your assignment one, people they have this sequence of operations, right? And they're like, well, okay, I need to print it out. And okay, I've got this queue thing, so I'll just print it out here because that's what I need to do. But it doesn't make sense to do it that way in terms of a priority queue is a general structure, right? So you really want to think about, okay, what am I building? What tools can I use to work on that? Because unless you do that, your code becomes, all tangled together, right? And you can't pull anything out of it, right? And the problem is in classwork, you never really have to do much with code, right? You make it work, you turn it in, I'm done, and you go on the next assignment. So you never have to worry about, well, I have to come back in 6 months and modify it to add this functionality. So you never think about how can I keep things independent. It doesn't matter, right? If your code is only 100 lines long, I mean, it could just be one long function, and you can make that work, right? When the code is 10,000 lines, that doesn't work anymore, right? When it's 100,000 lines, I mean, each one of those levels requires different types of organization to keep things working. So that's one thing, is just think about your code. How do I break it into separate independent pieces, right? So in the past, when I taught 535, I was like, that course was, what is an object? What's a class, right? What should a class be? What should an object be? That's it. That's all I wanted to get out of that course, right? To say, look, this is each class as independent as possible, and when should they be tied together or not? And so that's part of why we're talking about coupling and cohesion, right? Because okay, it also talks about, when should things go together? The other thing is, in the Java world, right, these patterns are fairly common. And when you go for job interviews, most of the time they're going to ask you, do you know patterns, right? And you want to be able to say yes. And then they'll ask you about patterns, and you want to be able to explain if they ask you about the decorator, the visitor, or any of these patterns. I mean, the goal is to be able to say, yes, I understand this, and I know what to do, how it works. Any other questions? So the immediate future, so a week from today, we get to have an exam. The event no one likes. Students don't like to take it. Instructors don't like to grade it or make it up, right? But it's comes with the territory, so we do it. So on Thursday, right, in 2 days, right, it'll just be review. And by review, what I mean is I'm not going to review material. I'm not going to come up with material and say, it's going to be, do you have any questions? Yes or no? I haven't done that yet. You should be able to find a bunch from previous classes, right? I mean, Yeah, it's from day 1 through today is what's going to be on the exam. Yep. Yep.
Pattern. We should know what it's.
The structure, yeah. Yeah, and the structure, what does it look like? How does it work? So I figure a week from Thursday, you'll know the visitor pattern real well. Right? Because usually, yeah, once you get it, it's like, what's the problem? I mean,
What's the hardest pattern?
um, the patterns of concurrency are harder. Concurrency. What's that? That pattern, there's a whole book of them. No. There's actually a whole book on how to deal with concurrency with Java. And the book is really, really hard. It's one of the hardest books I've seen, right? It's really deep. And so my answer is just to use the actual model and all that goes away. Any other questions? So we're talking about coupling and cohesion. Um, so one more topic I want to talk about was coupling and cohesion. Then I want to talk a little bit about metrics. Helps if I turn it on. Right, so the author wants to talk about object coupling, which is distinct from coupling between methods. And so it's got various different types of coupling. And so he talks about when we have a class, right, we can talk about how well things fit in that class, right? And that's cohesion. How cohesive is it? Do things belong there or not, right? But he also wants to talk about internal coupling as, well, things inside a class interact with each other, right? And so they become intertwined, and when they interact, that's coupling, right? And so we can talk about how well things belong in a class and how they interact with each other inside the class. Now, a classic example of this is a lot of people recommend that when you build a class, you got fields, right? Or data members or properties, depending on which language you're using. And then your code has to access those, right? And so some people say what you should do is for every field you have, you should have accessor methods that whenever you want to use that field internally, you call the accessor method rather than accessing the field directly. Why? Because as soon as you call that, as soon as you access that field directly in multiple methods, if you ever change that field in some way, then all your code has to change, right? But if you have accessor method and you always, your code inside the class only calls that accessor method, right? That isolates the rest of the code from some of the changes you might want to make from that with that field, right? And some people argue, well, that's too much, right? But that's an example of people talking about internal coupling. They say we want to reduce the coupling between the fields themselves and the rest of the code in the class, right? That's what some people say, right? And I think the best response I've seen on that is it sort of depends on how much work it is to go from one to the other, right? So if your tools make it easy to find every place you access that field and allow you to then refactor that automatically into a setter, then you have to use it right away or not. If the tool makes it easy, then what difference does it make, right? If you find later you need that isolation, right? But if a tool doesn't make it easy, then you may want to think about it. Yeah, I mean, whatever, if you're using IDE or you have some sort of program you can run to do it automatically, but usually it's an IDE now, right? And I've worked with people who do it, that they did that, right? They automatically always have accessor methods, and their code always did it. And the project I work on them, that was quite useful because we're doing some fancy stuff, and it's like, oh, okay, now in those accessor methods, we actually do extra things that turn out to be important, and it was easy to do, right? Okay, we didn't have to go back and refactor everything. It's like, okay, now we're ready to do this extra stuff, and it's automatically we're in place to do it. Yeah, then you got it, right? Yeah. But that's that's an example of worrying about object internal coupling. Interface coupling, well, it's just object only makes reference to one or more items in the object public interface, right? But that's sort of the weakest form of coupling between the objects. But there's a wide, he talks about there's a wide variation. We can talk about selector decoupling, constructor decoupling, iterator coupling, right? And by object abstract decoupling, usually he's mainly talking about generics, right? So, for example, you have a linked list, and so what items go in linked lists? Well, these days we make that item generic, right? And so we don't make any assumption in the linked list about what things it can hold, right? It's just type E. What is type E? Well, that depends when you instantiate the list, you can figure that out. So we're not worried about is it an integer, is it a float, is it a string, is it an object? Selectors, well, we had an example of this, right? In assignment 1, I asked you to print things out. And so what you do, you had a print statement, a print method, or display method in your priority queue. And the problem with that is it now couples that class to a particular output device, right? In that case, in your case, it was standard out. But if you instead return, for example, a string, right? Now we've decoupled our priority queue from that particular output device. And now I can take that string, I can put it standard out, I can put it to a file, I can display it on the GUI, right? So this, by selector decoupling, I mean, okay, instead of, internally in that object, doing something with that value, we're going to return it in some generic form, and then the outside role can decide what to do with it, as opposed to, oh, I'm going to print it out on the line printer. Well, who's got line printers anymore, right? Not very useful. And so my example is, yeah, so I've got a counter, and you want to display it as a, a progress bar, right? Once you display it, once your counter object, has the Java code in to manipulate that progress bar, you're dead, because that counter object can't be used anywhere else, right? But if instead you return the value as a count or a string, now we can have the view which will display, right, and get the value. And if later we want to, come on, desktop applications are old hat, right? We want to do it on the web. Well, you can't, how you display in the web is different, right? So once I get the value or the string, I can now display that in the web, right? So again, we're keeping, in this case, our objects decoupled from output or the view by returning a value, which I can then, it does require there to be a view, right, that handles that aspect. And whenever you're dealing with programs that display to a device, right, you have a view, you want the view to be separate from the model, where the model is, and every book will say that, but no book will tell you that that's very hard to do. And the iterator is another example of, right, separating these things out in terms of, well, how is a priority queue structured? How is a linked list structured? How is anything structured? Well, instead of having to worry about that, you get an iterator, and now it's next, 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 right? And I must admit I was surprised that in assignment 2, I don't think anyone implemented an internal iterator. An internal iterator is a lot easier to implement. Internal iterator? Well, an external iterator in Java is like iterator, right? So you've got a collection.iterator and returns an iterator, and then you have while has next, give me the next, do something, right? Internal iterator is where it's like, oh, I can just do for each, and I give it a lambda, right? And what happens then is I take this lambda and evaluate it for each element in the prior in the structure. Why is that easier? Because with the external iterator has to recall where you are. Keeping track, right? Whereas internal iterator, it doesn't have to remember. I have to stop and say, okay, I have to keep track of where I am. It goes here, 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 here. I'm done. Well, the simplest example, say I've got a tree structure, right? Doesn't have to be binary tree, just a tree, right? If I want to build an external iterator on this, what do I have to do? Right, but I'm going to point at the first node, but the problem is I come here, I come down here, right? And then I come back here. So I can be at a node several times, right? And now I have to remember, is the first time I've seen this node, the second time? And in this case, I may come back to this node multiple times, right? So I have to remember, yeah, the first time, the second time, the third time, right? If it's an internal iterator, all you do is, it's easy, right? You say, oh, I've got a lambda, I pass it here, and I say, okay, now give it the value of the lambda on this node, and then I call to do it on that node, and I call it on that node, right? And then when I'm here, I'll say, oh, I'll do it on this node, this node, this one, this node, and we're done. And it's all, there's no stopping.
How would you know that in this case, right side, go back to check the child?
Why do I have to check? It's like, okay, when I'm here, I say, if have left node, go there, and then if right node, go there. And it's one function, right? And you can make the call recursive, right? If I were to write a visitor to visit that tree, what do? It's like, okay, visit here, accept, right? And that's basically one function. Accept this, visit that, done, right? I don't have to keep track of when I've been here before. It's just here, there. I'm done with that function, and this one says, oh, visit, done, right? The author wants to try and understand how we can keep things cohesive. And so the idea of primitive methods is basically things that the only way you can implement it is with knowledge of the structure, right? In iterators, you need to know the structure, right? Otherwise, I can't iterate through it, right? And if you use Java's collection class, right? There's like 3 or 4 methods you have to implement. And once you do that, there's an abstract class you can subclass, implement those 3 or 4 methods, and you get all the other methods implemented automatically. Why? Because those methods can be implemented in terms of those small primitive methods. right? So there's a set of primitive methods we can usually implement that give us the functionality we need to make the object work. It talks about constructors. The problem with that term is people get used to the idea of constructors being a constructor in the language, whereas he just means a constructor is something that a method that returns, creates an object and returns it for us, right? And so a lot of times we get static methods that we can use to replace constructors in Java, because Java, it's hard to overload constructors in Java, because if you want one argument of the same type, you can't, right? Whereas here we can give it a static method and give it a name, right? We were waiting for you to start, but we just couldn't do it anymore.
You're gonna have to wait a little longer because I have to pee.
Too much information, right? This idea of primitive objects. When you think of Java, right? In general, we want our classes to be independent, right? So we can move them around. But in Java, you can't write much code without interacting with some of the data types that come with Java, right? Strings, right? It's pretty hard to avoid strings, right? And so he's, if we're going to talk about how objects are coupled to other things, right? Years ago, I had a student come into class, in the beginning of class, well, says, oh, by the way, I'm not going to be here on Thursday because I'm going to the baseball game. I go like, you probably didn't want to say that. It's one thing to say, well, I'm not going to be in class because I'm going out of town for work, or my kid is sick. But if you're going to a baseball game, you probably don't want. You just want to say I won't be in class, right?
Someone told you that they were in a baseball game?
What's that?
Someone emailed you said
No, they were in class.
oh, they're in class.
And they said, oh, by the way, I'm not going to be here in next class because I'm going to a baseball game. It's like, too much information for the context. Right? So the problem is, all our, our classes are going to be tied to strings or ints or floats or, dictionaries or array lists, right? And he's saying, well, we don't want to count that as coupling. Why not? Well, because if you're in Java, can you have Java without string? No, right? Can you have Java without array lists? No, right? What's that?
The main method is string.
Yeah, main requires an array of strings, right? Can you? Is there a Java implementation without an array list? Which means, right, if I have a class, I use an array list, any Java implementation we know of now, that class can be used there, right? So we don't need to worry about being coupled to those things because they always exist. Right. Yeah, that's what he's saying. Now you have to be careful because, of course, up until Java 9, most implementations had a swing classes, right? Except, of course, if you're building applets or you're running Java on the server side, then you don't want to be coupled to those, right? So you just be careful, right? We can't say, oh, we can be coupled to anything in the Java API. Because when you're on the server side, you don't want swing, you don't want FX. And you also be careful because at one point there was Java ME, right, which is for small devices, which had a much smaller API. Inside internal coupling. Yeah, so I talked about this earlier as an example of object coupling. With inside internal coupling is like, okay, between your fields and the methods in that class.
The previous slide, you have that time.
Well, but here we're talking about a single class, right? Accessing the fields in that class using access methods in that class. Not class A accessing things in class B.
So basically, don't internally to the class access data directly.
Right.
You can change the data structure to whatever you want.
Is the general for that for getters and setters, because this is something Python doesn't really enforce. But is like the whole point of getters and setters so that anyone using the object doesn't have access to how the data is actually represented inside of the object? Like it just gives them what they want, the format they expect. They don't.
Yeah. Again, this is as you point out, this is not a universal property, right? Because Python, they say, well, look, I mean, all fields are public, so anyone can access them. And here we're just talking about not anyone, but just methods in the same class. Like I said earlier, right? Some people say, look, this is going too far. If your IDE makes it easy to refactor, it's been decades since I did C++, but back then, refactoring or modifying C++ code is all done by hand. There was no IDE that you could say, generate accessors for this fields, right? It was you basically had a text editor, and that was it. There is sort of a problem with inheritance that people don't usually talk much about. So I basically say, look, we don't want classes to be huge, right? Because the bigger they get, the more complicated, and it's hard to maintain, and they're probably doing too much, right? Um, so we have, say we've got class A, right? And then we got subclass B and subclass C, and then subclass D, and then subclass E, and then subclass F, right? What's that? Yeah, so now if I think of A, maybe it's this size, right? But this size, I mean, it's got data members or fields and methods, right? But now, so this is A, but I look at an instance of B, right? B has everything A has, and it's got more. So it gets bigger, right? And then, D is even bigger. How big is it? Well, it depends on what D does, right? And then F gets bigger. But we're not done yet. The problem is, right? F can have methods that interact with things in A, right? And it may change methods in A, right? You can override methods in A. And so it's not just we've got a bigger class, we've got a two-dimensional class, right? Because we have what D does, and you have to go up one level, what this parent can do, and so as we get deeper inheritance structures, right? Our classes get bigger, and the interaction it gets more and more complicated because you can interact with your parent classes, you can modify what your parent classes do, and so it becomes harder to understand what's going on. It becomes more complex, right? And so part of what we're trying to solve with objects inheritance makes it worse, right? And so he's talking about this coupling, B, D, and F are coupled with A, and they can do various things, right? You can access their fields directly, right, and modify them, and that could interfere with how methods work in A, because you may not properly maintain the right value in fields, right? And so do you want to allow your subclasses to directly modify parent fields? People have stronger opinions on that because that field maybe, has certain values it can't take on because otherwise the parent class doesn't work. But when you do the subclass and down F, you may have forgotten that, right? And so you may change those fields. So it becomes safer, right, to only allow subclasses to access that state with accessor methods, because then you've got some control. And so when you try and change it to the wrong value, you can do something about it. Another problem is you've got F may inherit things that it doesn't want, doesn't need, right? And then what do you do? In Java, there's nothing you can do, right? I mean, with subclass, you get everything. In C++, you can hide things that you can hide your parent, but here is outside internal coupling from the side. Outside meaning class A can access things in class B, and you can access a private state. That's friends in C++. It's, C++ gets a bad rap. We can do the same thing in Java with reflection. And then Python, I mean, at least in C++, you have to declare to be a friend, right? You have to, the class has to give the other class permission to do it, whereas in Python, it's like, no problem, right? And often is there a problem in Python? Friend, yeah.
See it that are around.
Yeah, you have to be somewhat careful. Um, when I started teaching computer science, the um, the standard software engineering dogma was that languages like Python should not exist, right? The dynamically typed languages just were not safe and you should never use them. And by and large, computer science departments did not teach any language which was like Python. Um, and the reason was it just wasn't safe. Um, and the argument seemed reasonable, right? If you got a language where anyone can access the fields, you can muck it up, right? Some class over there can muck it up, and then it's hard to find because anyone could have done it. And how do you ever find that? And if you've got a program with 1 million lines of code, oh man, how could you ever figure it out, right? Those things are really hard. Once an object the state is transformed in an invalid state, and it can be very hard to find that. Then early on, I came across this book on Smalltalk, and there was this chapter. You read this chapter, most things made sense. There's one chapter I couldn't figure it out. I was like, what are they talking about? It doesn't make any sense. And so the only way I could figure it out is get a copy of Smalltalk and program it for a while. And so I did that, and it's like, and at one point, I bought this library to build the system, and the library, I mean, it was over 1 million lines of code. It was huge. And I was able to pull pieces out of it and use it in my code. It was like, but the standard software engineering people said you couldn't do that because it's not safe. I'm going, but I did it, and it worked, right? And so you have to realize, right, that some of what people complain about, they're not being totally honest because there's trade-offs, right? There are penalties for using types. Yeah, you can do that, but again, this is a convention. It wouldn't, but there's a way around that. Yeah.
You have a getter in a class and return the value. And you assign that value to a variable in Python. Are you is that variable now a pointer to that field? Or is it, it might depend on if it's a primitive or not, but if that field is another object, would it point to it?
In Python and in Java, right? Objects, when you have an object, any access to the object is a reference, right? And so when you pass that reference to someone else, you still pointing back to the original thing. In Java, no. Python, it's basically an int is wrapped in an object and stored on heap.
Is the
What's that?
value type in Python?
Int is an object. Everything's a pointer.
Deep copies, right? Like when you like set a value to a number and then set another variable to that expression, or the variable 1 to variable 2 to pointer, the second variable will actually be referenced in the same place. I feel like that's what I read somewhere. It's a simple object actually copies.
Probably. Otherwise, you go nuts with integers, right?
Yeah.
Everything.
But it's large structures. There's try to access. Yeah, you
So that's object and that's cohesion and coupling. So people, as engineers, people want to be able to measure things, right? When you say coupling, how can we measure that somehow, right? And so there's been a long history of in computer science trying to come up with metrics to measure how good programs are, how tightly coupled they are, and I want to talk about that a little bit. The problem with metrics, right? As soon as you create a metric, right, it drives behavior, right? If you work for a company and they've got annual evaluations, that drives what you're going to do, right? And usually it drives things not always in the right direction. Because like, okay, I mean, you said if I meet my goals, right, I do performance, I get a better raise, and so I'm going to do that. But what happens if what's good for the company is I do something else to, right, save a project over here, which is I'm not on, or, right? And so example here is, okay, I mean, you're going to pay someone for every bug they fix. Well, okay, there's no penalty for creating the bug in the first place, right? So
Is this kind of like a motivating activity? Tasks, and then you say points and like set your
what happened to the software development is people want to make it like engineering. And they said, oh, we want to make it like a factory. Once you build a factory, right? I mean, it's just a straightforward process. Blah, blah, blah. And so there was this huge movement to make it like that, right? Because, projects are always over budget and took longer than they should. And like, well, come on, can't we somehow make it like a factory where we know how long we input parts on one end, and we know how long it's going to take for the car to come out the other end, right? And so we want to be able to make software development like that. And so there's always techniques to try and do that. And at some point, people said, well, really, software development is not like a factory. Software development is like designing the factory, right? And that doesn't happen. It takes different amount of time to design a factory based upon the requirements, and right. So Agile was a reaction to, no, software development is not like a factory, right? And also, yeah, once you have too many metrics, right, you're trying to look at, it drives behavior in the wrong place. And so they were trying to pull back from that and say, look, just have a few simple metrics like, okay, you've got N tasks for this project, and how many are finished, how many are not finished, right? How many stories did we complete this week?
Meaning whatever like you have like in your mind, or like say like it's like what up with like that we're actually
Well, my favorite example for this is, I went through a project that it was a disaster. It was falling apart, right? But they filed all the paperwork, right? And so they had this process they were following, and you look at all the paperwork, and they met all the metrics. Everything like was on time, and it was like there's no code there. It was a complete disaster. But if you're looking at all the paperwork filed, right, it was like things look great. But people on the team knew that it was a disaster, but all the documentation, all the paperwork, all the reports were like, we're good. Right? I mean, you've seen this happen, right? It happens, and
eventually too late.
yeah. I once read a story where it was a big company, it was a national, big, huge company, and it was a project, a team of different areas, right? And and such, it was an important project, so the head honcho wanted monthly reports. But there's so many levels of management between developers and head honcho. It was like developers had to basically turn in their monthly report at the beginning of the month, which meant their monthly report was basically, I think I'll get this done this month, right? And then each level of management would say, oh, it doesn't look so good. I think they can get more done, right? And so the head level, like the report was always, this is great. And so it came time for different teams to get to combine everything in, right? And so they had this meeting where they took all the managers and flew them to one site to plan how, which member of your team you're going to fly to where to integrate everything together. And they met all day, right? Planning on where they're going to meet and who they're going to take. And then it's like 4 o'clock in the afternoon when everyone's about done. One guy finally said, I think my team really needs just a little bit more time, right? And of course, everyone else dumps on him, right? But after they're done dumping on him, I'm like, well, yeah, since he can use more time, I think my team can use more time, right? And eventually, everyone in the whole meeting agrees that, yeah, their team needs more time. The map said, we're done, right? We're finished. We're ready to go on the next step. But no, you have to go by what's in front of you, right? And that's the same with the metrics, right? The metric we say is great, but you still have to look at what you got and evaluate it. So Eclipse used to have these plugins to create metrics on code. This is getting old and they're hard to maintain, so I don't think they've maintained recently. And I don't know of any plugins that do the same thing with IntelliJ, because again, Agile people don't like to create all these huge metrics. So several different plugins, and then sort of standard metrics, right? So one is just how big is the thing, how many lines of code. But again, when you measure lines of code, yeah, but it came about because, we want some, how long is this project going to take, right? Is it going to take a week, a month, 2 months, 2 years, 5 years? And that sort of depends on the size, right?
I mean, obviously it'll grow with the size of the program, but it's not just
True, yeah, right. But the government contracts are like this, right? They require you to, give a contract, and you're going to build the system, and you're going to do it for a fixed amount of money, right? So you need to know how much to charge them. And so how long is it going to take,
Forever.
right? And so early on, this is a common metric. But again, the double principle, you have to, once you make that metric and make that your goal, then people can drive the behavior in the wrong direction. And so, right, the Barry, I remember his last name. I remember his last name is a famous software engineering professor at USC. Dr. Lane in our department was one of his students, and he came up with, various, how do you model how long it's going to take, how much it's going to cost you to build a system, and he created this model based upon an estimate how many lines of code it's going to take, right? And so he creates this model, A times number of code raised to B, where A and B are parameters you figure out, right? And then he measured a bunch of projects and created various values. But in general, the idea was, as a company, you'd sort of, as you do more and more projects, you'd sort of measure how long it took, and then you would figure out how many lines of code there were, and then you'd sort of compute, the type of project your company worked on with your developers and your language and your domain, what A and B were. So as you move forward, when you had to bid out contracts, you could have some sort of metric to use to figure how long it's going to take, how many lines of code, how many developers, right? Yeah, but so the idea here was, if one company is using C++, one company is using Java, and one company is using Python, right? Their A's and B's will be different based on the language they use too, right? And so the goal was you would then measure how long projects took and how many lines of code there were over time to evaluate what your A's and B's would be based upon your developers and your language and the type of things you did. But yeah, I mean, the different language would be different, and so the goal wasn't, oh, here's A and here's B, and then you plug it in. It's like you have to figure out what your A's and B's are based upon the language, developers, domain. Right. And so, yeah, I mean, different languages, but again, if you're on a contract, you have to figure out how much to charge people, right? And typically you do it per project. And if you're not careful and the project takes you 3 times longer than you thought it would, I mean, you lose money. And so we need some way of trying to estimate. And so this becomes one natural thing to try. And so all these metrics, I downloaded a Twitter client source code and then measured it. And to figure out how many total lines of code, right? And just to see, and it shows you, different packages. And if you want, you can dig down different classes and see each class. And then it'll generate how many lines of code per class and average per method. And that can be instructive in terms of, well, look, right? That's 5 and that's 26. And that's the mean number of lines of code per method. Like, oh, what's going on there, right? You may want to look at that. So in that way, if you use it instead of trying to punish people or pay people, it's like, oh, let's use it to investigate what could be a problem in our code. It becomes a useful tool. And that's why I started with saying that, when you use metrics, it drives behavior, right? So if we can get beyond that and say, look, okay, there's something going on here, we should look, right? Because it's clearly out of bounds, and that's pretty high too. So what's going on, right? Why is that? And it turns out the answer is because the examples have interface GUI code in it, and those are really long. It's like, okay, that makes sense because you have this big, huge. The other plugin, it shows you, well, there were like 35 methods which had 2 lines of code, right? And then there's 3 lines that's really popular and a down and sort of bell curve. And then there's a bunch of methods that have more than 30, right? So maybe we should start looking at some of those just to see what's going on. And then, of course, the lines of code or statements, right? These are a number of statements. And then once we're looking at sizes, we can ask how many packages there are, how many classes there are, how many classes per package, right? Again, is one package really large and one really small? Another common metric is called the McCabe lecmatic complexity. And the idea is, how complex are your functions, right? If you've got 10 assignments in a row, not very complex. If you got if statements, more complex. If statements, embedded if statements, more complex. If and if, oh, that's terrible, right? So the goal is, can we come up with a metric to sort of look for complexity, and then again, just use it as a way of saying, oh, let's look at our code and see if we've got some hot spots we should look at and examine. So the idea comes from graph theory. So it's the number of edges in the graph minus the number of nodes in the graph. And then P is the number of connected components. What does that mean? So here's an example of taking code, right, and then turning it into a graph. And the graph is basically different ways you can flow through the code, right? So you got 2 if statements. And so those 2 if statements give us, right, this graph. And so the number of nodes is 7, number of edges is 8, and it's all one component, right? They're all connected. And so the complexity is 3. Right? And if it was just straight line, then the number of edges would be the number of nodes, right? And so it'd be smaller. And so it does several things, right? The higher the number is, the more complicated the method's going to be. And this complexity number is larger than the number of branches you need to cover, but it's less than the number of total paths through the. Right? So people have studied it and they say, yeah, it's basically seems to indicate, and National Institute for Testing, right, has this big software group, and they say basically once that complexity gets larger than 10, it's probably too complicated. You need to break it into smaller pieces, right? And so again, I run the metrics on this project, and the median complexity per method, right? The standard deviation and the maximum. So, right, some packages have method with complexity 46. We may want to look at that, right? But again, the problem becomes if we can use this as just as a tool to say, oh, let's like a microscope, right? Well, let's examine it and get a better view of our code, what's going on. And that's one thing. But if we use it as, well, your code has complexity 13, so you are not going to get a raise this, right? Then what's going to happen is people are going to write code just a metric, not necessarily because it's a good thing to do. And then, various plugins do various things. And then they start doing things, well, how complex is a class? Well, we'll take the complexity for each method and add together and average it out to figure out complexity for the whole class, right? Some companies used to do it. I don't know if they still do it. The problem is, if you've worked for a company and we start doing metrics like this, it starts driving behavior, right? They start you saying, okay, she had high complexity, so no raise for her this year, right? It's very tempting for managers to do this. It's also very tempting for managers to use the metrics instead of understanding what's going on in the team. Right? Understanding what the team is doing, what shape the code, it's a lot of work and it's hard to do. But, I guess we're good. I guess we're bad. I guess he's good, she's bad. Based on these metrics, is very simplistic. And there's lots of metrics like this that we can talk about. They won't be on the exam. I'm not going to ask you about the metrics, but it's things you should know exist. The agile movement is not friendly to such metrics. That doesn't mean they can't be useful used in the proper way. Okay, well, bring your questions on Thursday.